Hi, my name is Ginelle Maldonado.
I'm Julie Timmermann, and we did our vaccine proposal on hookworm, specifically hookworm caused by Necator americanus. I did the literature review, so this is just a little bit of an introduction. Hookworms are soil-transmitted parasites that attach to the small intestine, and they're able to easily evade the human immune system due to a protective sheath around them. So our proposed vaccine targets their ability to evade human immune responses.
I did the vaccine design. The infection by hookworm is not localized at a point since it travels from the skin to the lungs and finally to the intestines. In order to combat the disease at different stages, it is important to treat it by introducing various cytokines that will induce antibodies and T cells corresponding to the stage of infection.
And this is just a little bit more in depth for the literature review. Like I mentioned before, hookworms infect humans by attaching to the small intestine. And then once inside the small intestine, they lacerate mucosal blood vessels and produce a variety of anticoagulants and proteases. And that's just a figure of the parasite attaching to the small intestine. Hookworms are able to evade the immune system and survive for years due to their larval sheath. And since they're so good at avoiding the immune system, we will need to stimulate Th2 response and IL-4 production in order to target that problem.
Our vaccine is composed of 2 doses. The initial dose contains IL-23 cytokines, which are administered intranasally, will induce the production of Th17 cells that would result in protective immunity in mucosal surfaces such as the lungs. This figure right here just shows the staging at which each vaccine is administered. After 10 days from the initial dose, IL-4 cytokines should be administered subcutaneously to cause the formation of effective Th2 cells, which will secrete cytokines to promote IgE antibodies. This will aid the identification of the parasites and eliminate them.
And that's all for us.
For the efficiency trial, this study involves testing a vaccine on laboratory mice with a focus on adult and elderly stages to assess its potential for human adults and elderly individuals. There will be 2 groups in this experiment, the experimental group and the control group. One will receive the vaccine and the other will receive a placebo before exposure to the Necator americanus larvae, which will also be in a controlled environment. There will be data collection over a 4 to 6 week time period where we will assess the vaccine's efficiency, considering parameters such as fever, swelling, lethargy, and skin redness, pretty much taking in all the symptoms that you could possibly get from the vaccine and see if they're dangerous or if they are safe. Post-examination will ensure the vaccine's safety in the vaccinated mice. And hopefully, if this all goes well, we can bring it to the next stage, which will be human testing. And then after human testing is done, maybe it could be released to the public.